A tipping point is something that happens to the climate system that's irreversible on human timeframes. Can't get back to the old climate state, not for potentially millennia. The one that matters for Antarctica is essentially the point at which the ice shelves are all gone. And that will cause very rapid sea level rise above the levels of the current projections. So the Antarctic ice sheet itself sits on continental bedrock. But the ice essentially flows from a high point to a low point, then it hits the ocean, and so it flows onto the ocean, it floats on the ocean, and we call that the ice shelf. There are ice shelves all around the coast of Antarctica, and what these ice shelves do is they hold back the ice flowing off the continent. Unfortunately, these ice shelves are all melting, they're all thinning because the ocean is warming, and in some places around West Antarctica it's warming a lot. The Larsen ice shelf, for example, the size of England, and it essentially disintegrated in a couple of months. Then what happened? The glaciers feeding the Larsen ice shelf sped up 10 times. So we're seeing that happen all around Antarctica, and once they go, then there's nothing to stop the rest of the ice sheet just sliding into the ocean. Now there's another instability. So West Antarctica essentially sits in a big bowl, 2 kilometres below sea level. So that warm ocean nibbles away at the edges and gets into the soft underbelly. The edges of the ice sheet start to lose the grip on the side of the bowl, and so what happens is it's like a bunch of dominoes falling over. These ice cliffs just topple. And we've seen that in Jakobshavn Glacier up in Greenland. You know, it's an incredible thing to watch. These immense ice cliffs, 30 kilometres long, just boom. And if that really plays out at large scale around Antarctica, we're grossly underestimating the amount of sea level rise from Antarctica. Ultimately, the key thing is carbon dioxide warming the climate. And CO2, the greenhouse gases, and Earth's temperature are totally locked. We know from ice core records and geologic records that you have to go back 3 million years to see a time when our planet last had 400 parts per million carbon dioxide on the atmosphere.
Here we have the Andril drill system sitting here on the Ross Ice Shelf.
We drilled back to sediments that were 3 million years old to answer that question: when CO2 is at 400 parts per million or higher, what happened to Antarctica? And we know that the Ross Sea was 5 degrees warmer. The Ross Ice Shelf had collapsed. There is no West Antarctic ice sheet. And not only that, we know from other drilling projects that big parts of the East Antarctic ice sheet also disappeared. Global sea level records from around the world tell us that sea level was about 20 metres higher. So the Paris target says we must limit global warming to less than 2 degrees. And this is one of the reasons. It's a tipping point for the Antarctic ice sheet. Even if we achieve the Paris target, we'll get 50 centimetres of sea level rise in a century. That's baked in from the heat that's already in the system. 800 million people around the world are going to be affected by high tide flooding. And so, you know, Hurricane Sandy that wiped out big parts of Manhattan.
Water is splashing over the seawalls at the tip of lower Manhattan.
Those sort of coastal flooding events will be an annual occurrence. And we can't avoid that. That's locked in. So we've got to adapt to living in a warmer world. The latest generation of ice sheet computer models are incorporating these instabilities, predict up to 2 metres of sea level rise a century, unless we aggressively reduce our emissions. People feel it's a hopeless situation, and it's not a hopeless situation. In fact, the science tells us we still have a chance to solve this problem, get on top of it anyway, and avoid the worst. Just in the last few years, we were seeing a sea change in the world. It requires a global response, both in terms of how we save the climate and in terms of how we save ourselves.